Okay, number 6 in your lesson is exactly like number 3. It's literally the same problem, they just changed the number. So you can go back to your information for number 3 to work out number 6. And 7 through 12 simply change the shape that we're working with from an equilateral triangle to a regular hexagon. What we need to know from this is that the word regular means all sides are equal. And obviously a hexagon has 6 sides, but what's most important is that a hexagon is actually made up of 6 equilateral triangles. Now, drawn this picture, my regular didn't really take effect because all those sides are supposed to be equal. Obviously, I drew this much longer than the other sides, but bear with me in my drawing skills. But if we were to break this out, we would actually find, that we have 1, 2, 3, 4, 5, 6 triangles in this hexagon. And again, if I had drawn it actually all sides equal, all of these are equilateral triangles. Okay, so if this right here is an equilateral triangle, it means this side equals this side equals this side. Okay, so whenever I'm given a side of a hexagon, I actually know the side of one of the triangles. Or if I'm given, which is a radius, right? Or if I'm given a radius, I actually know one of the sides of the hexagon. Also, the other important thing is that everything we learned about equilateral triangles then still holds true. Things like the apothem forms a 90-degree angle and it bisects this bottom, okay, and it makes a 30, 60, 90 triangle, which is important because we use those in here, right? So everything that we learned about equilateral triangles is going to be put into place with our hexagon problems. And the other thing we need to know is the formula for area that we're given for the hexagon. That's in this lesson, it's theorem 8.4, okay? That's a colon. It kind of looks like an 8, but sorry. Which says that area equals half the apothem times perimeter. And the reason we're actually still able to use this, even though we just used it for a triangle, is that this theorem applies to all polygons who have equal sides. Okay, well, a triangle is a polygon. The equilaterals, well, they had equal sides, right? A hexagon's a polygon. When they say regular, it means it has equal sides. So we could actually use this formula for regular octagons or septagons or anything else, as long as it's a polygon that has all equal sides. Okay, so enough of that. I'm going to attempt to draw maybe a little bit better of a picture for a hexagon. But we're going to look at number 7 to start off with, and then I think, well, that's terrible. And then I think you'll start seeing a pattern that kind of looks like our triangle problems, okay? So number 7 tells us to find the area of a hexagon that has a 4-inch side. Well, I'm not going to use 4, so you can, figure this one out by your own, but I'm going to change mine to 6 inches, okay? So I have a side that measures 6 inches. That's all I have, and they tell me to find the area. Well, I know that I'm going to be using this formula, half times apothem times perimeter. Well, right off the bat, which of these can I find if I have a side? The perimeter, right? It says add up all the sides. Well, they only gave me one side, but what do I know about regulars? They're all the same. So that's 6, that's 6, that's 6, that is, and that is. They're all the same. So I now know, well, my perimeter is then 36. Okay, good. So now I have to find this apothem. In order to find the apothem, it's probably important that I actually draw an apothem on here. So if you'll recall, apothems go from the center of the polygon straight down to the base. And remember, straight meant that it's a perpendicular, which means it forms 90-degree angles, right? And of course, we always see apothems with radii, right? So I want to then draw in some radii. Radius goes from center to vertex, correct? Now if I went from over here, center to vertex, I have created this equilateral triangle that I was talking about, okay? Equilateral means all sides are the same. So if this is 6 inches and it's equilateral, what is the measure of this radius? 6 inches. So now I need to find A. And just out of curiosity, even though it doesn't actually pertain right now until we get down here into our proportions, but if this is an equilateral triangle and this is our apothem, do you remember what it does down here? Breaks it into halves, right? Equal halves. So that means that this whole thing's 6, then this little piece right here must be 3. Okay? So now I'm going to set up my two 30, 60, 90 triangles so that I can find that missing A. It's really crooked. All right, so there's my A. We know that radius is 6. Now I know I split that in half and I have a 3 down here. Okay? And then we have our 30, 60, 90 guy. Ooh, hello. And remember 30, 60, 90s go 1, 2, square root 3. So there's our 2, 1, and square root 3. Okay? Now all we do is set up our proportion. So again, I work left to right. So 6 over here corresponds to 2 over here. Okay? A over here corresponds to the square root of 3. Cross multiply, so I have 6 times the square root of 3 equals 2 times A. Get the 2 off by dividing. That cancels. 6 divided by 2 is 3. So I now know my apothem measures 3 square root 3. I'm going to take that information, put it right back up here where it belongs, 3 square root 3. Okay? So to finish finding area, I do half times 3 square root 3 times 36. Now, I'm really big into taking halves in my head and continuing on, but I can't half 3 because it's 1.5, and that's not fun for multiplying. So I'm actually going to skip this, move over here. Half of 36 is 18. So I have 18 now times 3 square root 3. So then all I have to do is multiply 18 times 3, which is 54 square root 3. Of course, it's area, so that's in our units squared. Okay, so that's your answer, 54 square root 3, because we found area. Now all we did was we knew it was a hexagon, but what did that really mean for us? Oh, it's broken up into equilateral triangles. I can use my 30, 60, 90 to find the missing pieces. Okay, number 8, just looking at it, gives you the same problem, but this time they say find the area of a regular hexagon if you're given the perimeter. Well, the perimeter is actually super helpful because that's in our formula, right? So it says our perimeter in this instance is 48. So we don't have to do any adding. We just go ahead and drop in where it says perimeter, 48. Okay? Then the next piece to find the apothem, well, that obviously takes a little bit more work. We've got to go back down here and do the exact same thing as we did in number 7, except for we're not given the side. But if I'm given the perimeter, and I know that all sides are exactly the same, I know I have 6 sides that add up to 48. So all you do is divide 48 by 6, so now we know, okay, each of my sides is 8. Then we're literally just doing problem 7 over again from this point. Instead of 6's all the way around, we're going to be writing 8's all the way around, right? And If this 8's cut in half at the bottom, that means this piece is going to measure 4. Okay, so number 8 is just like number 7. We simply had to find our side all by ourselves, and we did not have to add it up to find perimeter because they gave it to us. Okay, number 9 is kind of the same, a little bit different. So I'm going to draw that picture out because in number 9, they actually give us the apothem. Ooh, see, ink going through. Oh well. Okay, I'll go ahead and use this one since it's already kind of drawn out here on the thing. All right, so it's the same regular hexagon, so we know all sides are equal again, except for this time they're giving us this apothem, and they're saying it measures 2 square root 3. And I have to find area. So I'm still going to be using Theorem 8 for, that says area of a regular polygon equals half apothem times perimeter. Now what's the good news here? Oh, I don't have to go find my apothem, do I? They already gave it to me. So I can insert that 2 square root 3 right there. And so now I'm just left to find perimeter. Well, what do you need in order to find perimeter? To find perimeter, you add up all the sides. I don't have any sides, right? So I need to find this whole side. And the only thing that I know how to work with are these triangles, right? And so I know then if I can find this side, since this is an equilateral, this equals this, right? So all I have to be able to do is find this radius. Remember, in a regular hexagon, the radius and the sides are equal. We learned that right here on this paper where we talked about creating equilateral triangles. Okay? So, here I conveniently have my apothem, which creates a 30, 60, 90 again. So I'm going to redraw that down here so we can see it better. The apothem is 2 square root 3, and I don't know the radius. I don't know this either, so I'm going to put an X, okay? And then I draw my 1, 2 square root 3. Oops, kind of messed that one up there, sorry. Okay, so to find R, well, I could say R corresponds to 2 square root 3 corresponds to the square root 3, and we cross multiply. So I have I'm right over here, square root of 3 times R equals 2 times 2, sorry, that's running away, square root 3, okay. Now then, 2 times 2 is 4, so that's 4 square root 3. I have to slow down my writing, my paper is moving all over the place. There we go, okay. And how do we get the square root of 3 off of R? We divide of both sides. By the square root of 3. That means this guy cancels. I'm left with R equals 4 square root 3 over square root 3. Okay? Now, algebraically, this is technically incorrect. You're not supposed to leave any answers with a square root on the bottom. So we're going to have to get it off. How you get this off is you simply multiply the top and the bottom by whatever the bottom is, okay? So in this case, the bottom is the square root of 3. So I'm going to multiply the top and the bottom by the square root of 3. Reason is, if you look at the bottom, look what happens. What's the square root of 3 times the square root of 3? Square root of 9, right? Square root of 9 is 3. So look, I no longer have, I no longer have that square root in the bottom. Then up top, I end up with 4 times square root 3 times square root 3. Well, again, square root 3 times square root 3 is square root of 9. Square root of 9 is 3. So on top, I have 4 times 3, which is 12. 12 over 3 is 4. So now I know my radius is 4. Now, technically speaking, there is a much easier way that you could do that. If ever you see that there's no coefficient out here, coefficient means a number. If there's no number out here and these guys match, you can actually just cancel those and end up with 4. Okay, so our radius is 4. Go back up here to the picture. If I know my radius is 4, and I know that this is equilateral, then I know that my side is also 4. So you just bring your information up here, calculate perimeter. Now I know this side's 4, it's regular, so they're all 4, right? So add them up, insert perimeter, multiply these guys out, and you'll get area. And this one I actually used the number they gave you, so I'm not going to finish working it out. You need to finish working it out. So calculate perimeter, multiply them all together, and then you'll have your answer for number 9. Okay? Number 10 is asking for you to find the area given the radius. We just learned that the radius equals the side. So this is exactly the same as number 7. So number 10 and number 7 are the same, okay? Because when they say the radius is 6, that means your side is 6, okay?